Hello everyone. In this video we will discuss about the physical and chemical properties of alkane, and you will appreciate where they are being used. So the alkane with 1 to 4 carbon atoms, um, like methane, ethane, propane, and butane. I'm not gonna name all of them after this. Butane. So these are usually gas, so that's their physical property. So if they are gas at the room temperature, obviously they should have a very low boiling point, right? So 1 to 4 carbon atoms are usually gas, and obviously we use them in our heating, right? Like we make uh, we burn the gases to cook food or to heat our houses. So they can be used as fuel. So they are used as fuel. If it's between 5 to 8 carbon atoms, like pentane, hexane, heptane, and octane, so these are liquid at room temperature. And they are also used as fuel, and they are used as fuel in our like vehicle flights and all those things, right? uh, Anything above that, like 9, so then the density comes into play. Some of them are solid, so anything beyond 8, they are likely to be solid or very not as fluid as this. So if it's above 18, greater than 18, they are gonna be definitely solid, and most of them we use them as lubricants. And the engine oils, like anything between 8 to 18, we can use them as lubricants, engine oils, and the parafilm. Okay, so you don't need to focus too much anything beyond 5 to 8. So in simple term, longer the carbon chain, higher the melting point. Higher the melting point and boiling point. So as you can see, if you go above 18, they started becoming solid, like Vaseline, right? The Vaseline. Uh, so higher the melting point. So I could ask you question in exam: propane and octane, who has higher boiling point, or let's say higher melting point? It doesn't matter. So what you're gonna say, the answer is octane, because octane has 8 carbon atom and propane has 3 carbon atoms. Good. Okay, so what if the chain is branched? So let's compare this. Butane versus, there is a nickname for this one, which is called isopropane. We have drawn these two structure before, so let's draw the butane. Butane is CH3, CH2, CH2, CH3. Isopropane is the exact same. So these two are structural isomers: CH3, CH, CH3, CH3. So that's our isopropane. So if you look at the molecular formula for both of them are C4H10. They are structural isomers of each other. So these are structural isomers because they have the same formula but different structures. Now, how does the melting point and boiling point compare? So before we jump onto find out how the melting point and boiling points get affected in this scenario, you don't need to remember the exact number, but you need to appreciate how different they are because of the structure. So let's do it. So alkane is, well, this is our butane, right? So butane can be stacked on top of each other like this. So each of those lines are tightly packed, right? So it's tightly packed, tightly packed. And what happened during melting or boiling process? So during melting and boiling process, what you do is you separate them. You separate individual molecule far away from each other. So if you remember, in solid, the molecules are tightly packed. Then when you heat them, they turn into liquid, and liquid is not as tightly packed. So this is solid, this is liquid, and if you heat them, then they become gas where they are farthest apart from each other. So the distance between each of those particles is going up as we go from solid to liquid, liquid to gas. So to separate them, you need to apply heat or energy. So the tighter they bind, harder to separate. So tightly packed, which means harder to separate. But imagine this, because this has a uniform structure for butane, it's kind of nicely packed, right? But how does the structure of this looks like? This looks like this. So this one won't be able to tightly packed. So this one's, it's like very odd structures, right? So this one is pretty odd structure. So this one cannot be packed nicely. So if it cannot be packed nicely, which means it's easier to separate. So if it is easier to separate, what does that mean? Less energy is needed. Less energy needed to separate. So if you have to apply less heat, that means they should have lower melting point and boiling point. Okay, so you have to compare of the same molecular mass. So both of them are C4H10. All right, so because these cannot be packed tightly, so it's gonna be easier to separate. If it's easier to separate, that means less energy is needed to separate. That means it should have lower melting point and boiling point. Good. So let's do another quick example. Between this, so this is, what is it, 1 2 3 4 5, this is a pentane. So this is 5 carbon atom, this is 1 2 3 4 5, this is also 5 carbon atom. So both of them should have the same molecular mass. So in this case, who should have higher? So question is, who should have higher boiling point? Who should have higher boiling point? So this one is straightforward. So anything that is branch is gonna have harder to like easier to separate, I meant, which means less energy. So it's gonna be lower melting point. So this one is gonna have higher boiling point. So that's the answers. So in summary, straight chain is gonna have higher boiling point and melting point in comparison to the branch chain, as long as they have the same carbon atoms. All right. So that's about the melting point and boiling point. You don't need to memorize the number. Just look at the structure and say a comparative numbers, right? Next one is solubilities. This is pretty easy. We all know that oils, our gasolines, they are not soluble in water, right? So these are insoluble in waters. Like you have seen gas oil floating on top of water. So if the oil is floating on top of water, so what should be the density? Density is always lesser than water. And how do we know that? Because it always floats on top of water, right? So if you have water and then you put oil on top of it, then it's gonna float on top of water. So in terms of soluble, water is a polar solvent. So I'm gonna rewrite here. So water is a polar solvent. All the alkanes are non-polar. All the alkanes are non-polar, which means these don't match. So that's why they are insoluble. So alkanes can be soluble if there is a solvent that you can find non-polar. So they would be soluble. But since we are talking about comparing water versus alkane, so they would be, you cannot mix them. They will be insoluble. Okay, last portions, the chemical property, which is reactions. Uh, all the alkanes, they don't do too much reactions. Only thing they do is they burn, right? So we know that we cook food by burning all sorts of gases, propane, butane. So what happens? CH4 reacts with oxygen. So if you light them up, if you heat them a little bit, they're gonna catch fire. They're gonna produce carbon dioxide and water, and obviously you're gonna produce heat. So that's the only reactions these alkanes do. There are a bunch of other higher reactions we're not gonna cover in this video or in this topic or in this chapter. Uh, but these are the basic reactions that you need to know. Okay, let's balance the equations. So we have two here, two hydrogens, so that's four balance. Oxygen needs to be balanced as well, so two. The same thing will happen, you do any sorts of alkane. So let's say propane, we are barbecuing with the propane tank. So this is propane, right? So this is our propane. You write like this, or you can write the actual formula, which is C3H8. Remember, how do I get this C3H8? It's always CnH2n plus 2. So this is 3 multiplied by 2, 6 plus 2. Always add 1, 2. Okay, then they burn in oxygen, and obviously they're gonna produce carbon dioxide and water. This is always the case. And obviously we're gonna produce heat because we are cooking our food, grilling our meats or vegetables. Okay, now all you have to do is balance. We have 3 carbon atoms, so we should get 3 carbon dioxides. How many hydrogen we have? 8, so we should get 4 water. So now how many oxygens we have? We got 4 oxygens, and here 6, so that's 10 oxygen. So we'll add a 5. All right, so the basic things that you need to know is all the alkane, they bonds in oxygen to give you carbon dioxide and water. All right, so I'm gonna stop here.